So now let's look into the second type of data encoding or second technique under data encoding section, which is one-hot encoding. So we use this category we use this categorical data encoding technique when the features are nominal that do not have any order. So in one hot encoding, for each level of categorical feature, we create a new variable. So each category is mapped with a binary variable containing either 0 or 1. So here 0 represents absence of that, 1 represents the presence of that category. So let me make it much simpler. So one hot encoding and one hot encoding are essentially the same as essentially come from the fact that one column in the resulting encoded data has a value of 1 indicating the presence. I'm repeating that the term one hot encoding comes from the fact that only one column in the resulting encoded data has a value of 1 which indicates presence of it for each row, and all other columns have a value of 0 indicating absence. So this creates a hot or active encoding for the particular category. Okay, so that's where the one hot encoding came from. So now let's visualize the one hot encoding. So let's take this is a data set. We have a data set. Let me write down here. One hot encoding and put it here. Yep. So let's take a data set of employees. Oh, sorry. Let's take a data set of. Let me look into this. Data set of animals. Its data set belongs to Jew. So this data set consists of information about the animals in that zoo. Okay, now so obviously in the animals category, in the animal variable section, in the animal variable you will have all the animals like dog, cat, sheep, horse, lion. Okay, so now so this animal variable is a nominal variable, and it consists of only 5 categories, which one is dog, second one is cat, one is dog, second one is cat, and third one is sheep, and fourth one is horse, and fifth one is lion. So total 5 categories which does not have any order. So that is the reason these are nominal variable. Okay, this is what is our data set. So now there might be 2000, let's take 2000 data points of this animal data series. In that 2000 data points you will have this dog, cat, sheep, horse, lion will be repeated a lot of times. Okay, that's the overall data series of animal variable. Okay, now what's the next? If you want to convert this into a numeric variable, so then you can go for the one hot encoding because this is a nominal variable. So let's do one hot encoding. So in one hot encoding what we will do, so this is how it will be transferred. This single animal series will be transferred into 5 variables. These are called dummy variables. So each dummy variable will take the variable name of the category. So So dog is one category of animal variable that has taken one column, and cat another column, sheep another column, lion another column, horse another column. Okay. Now, so now how it works? Whenever, so total you have 5 dummy variables. In that specific row, if dog exists, so dog will take up, the presence of dog will take up value 1 and rest all will take up 0. In that specific, see here, dog exists, dog's presence had made dog to take up value 1 and remaining all other categories, all other dummy variables will be 0. And then you have a cat, dog is absence, so it took 0 and then cat has taken 1. And similarly, sheep, again sheep has taken 1 and remaining other dummy variables has taken zeros. And same applies to the lion. Lion has, and then you see that lion has taken 1 and then remaining all other, for that specific row remaining all other has taken zeros. And same applies to the horse. Okay. Now, how the computer understands this is, when dog presents, it will take this binary code 10000. That's how it process it. When cat is there, then in that row the value it will consider is 01000. For sheep 00100. These are all binary codes. That's how this categorical variable will be OneHot encoded into these binary values. Now let's get into one example to have a clear cut understanding about that. First we will see the hard coded one, then we'll go for the module one. So here I will take up a simple example. I'll take the same one. So what all I have here, a dog, cat, sheep, horse. Okay, let me create a data frame first. In that case, let me create a sample data frame. So df, this is OneHot df1, df1h, OneHot encoding. So pd dot data frame of animal, and as usual it's what's that, let me put into the same one, dog, cat, dog, cat, sheep, lion, and the final one would be horse. Okay, and let me repeat them. Yes, that's it. Your data frame, his data frame is ready, and this is what is your data frame. Total 64 rows. Now it's time to perform one hot or active encoding on the sorry, what's that, it's animal. Yep, it's animal column. Okay. df1h encoded is equal to pandas dot get dummies. You see that, the get dummies of whole data frame 1h, and then columns, specifically it's animals. Okay, animal, and df1h encoded, and here is your encode. So the whole data has been encoded. So for the better results, let's concatenate df1h encoded and df1h so that we can see them together. and that's what at the end of the day we want. So df concatenate is equal to pd dot concat of df1h and df1h encoded, and I'm gonna go for the axis. That's 1, axis is equals to 1, and rest all done. Let me close this first. Sorry, and that's it. Let me print it now. Print it, df concatenate, and here is how the result look. Animals and animal cat. Let's cross check. Dog, you see that for dog this is what the binary code you will get it, 0 1 0 0. For cat 1 0 0 0, and for horse 0 0 1 0 0, and for sheep 0 0 0 0 1, because animal sheep is here, and then remaining 4 dummy variables will be with the 4 zeros. Okay, so that's how overall hot encoding works. OneHot encoding works. So now let's use OneHot encoder module from the, let's use OneHot encoder module to do the same. So let me import that from sklearn and pre-processing. Just import whatever is required, that is OneHot encoder. Ordinal encoder was done. Now we'll be looking into the OneHot encoder. So we have our df1h ready, so that is what our data frame. Now let me say encoder is equal to OneHot encoder. So the defining the referring OneHot encoder method with the variable name encoder is done. Now it's time to perform OneHot encoding. So df 1h encoded, df1h encoded mod is equal to, so pd dot data frame, and inside that I have to give the encoder. Of course that's OneHot encoder, and I have to fit transform, and what I want to use in fit a transform. So here I want to use that specific encoding method. So let me say df1h, and it's animal. I just want to convert this to array, then as usual I'll go with the columns. Columns is equal to the encoder dot get features names out. Let me, yeah, features names out, and it's animal. So so get feature names out is animal. So now let me cross check my overall statement. So data frame encoder fit transformation, and inside that I'm gonna give animal, that's my variable name, and then get features name out. Okay, that's it. Now let's encode. So now let's concatenate the df1h and then df1h encoded. So concatenate the original data frame with the OneHot encoded data frame. Okay, so df 1h concatenated is equal to pd dot concat. As usual, we have to give both df1h and df1h encoded, yeah, and then axis is 1, and that's it. It's time to print df1h concatenated, and here is the magic. So total 64 rows and 6 columns we did with the module called OneHot encoder, which is from sklearn pre-processing. We used a pre-processing module, and this is what is animal, and this nominal variable has been OneHot encoded into 5 dummy variables based on the 5 categories: animal cat, animal dog, animal horse, animal lion, animal sheep, and then the explanation goes same way. So with this, we have come to the conclusion of for the nominal variable OneHot encoding fits very well.